Hey guys, so I'm trying out a different form of video because exercise 6, I finished it and it all got corrupted. So we're just gonna run through this super fast just because we're gonna be doing this in lab again and we can talk about this more in detail. So let's just hit exercise 6 and hopefully we can get through it real quick. So to start off with A, that's just gonna be the overview. We're gonna be talking about bones, muscles, and then we're going to be talking about lever actions, which I'll post a TechSmith over a slideshow, just because that's kind of generally the hardest information that I think that we go over in the entire semester. So we'll just dedicate a whole slideshow to that one. So for B, we have long bone gross anatomy. And what we have first is we're just going to do only ID. You guys can do description on your own. Please make sure to fill that out. It's just a whole lot easier to study when you have more complete information. So to get started, what we have is your diaphysis, which is kind of the middle part of the bone, excluding the ends, where your epiphysis is going to be the ends of the bones. Articular cartilage, as the name implies, we have anywhere where it articulates with another bone. So right here is where your articular cartilage is going to be, and it's going to be on the outside of the bone as it is cartilage. Your epiphyseal plate / line is where the difference between compact and spongy bone begins. So usually it's right here, or it could even be cutting like this in between the two and right there. And so it's just an imaginary line just separating between the two types of bone. Your middle is going to be that compact bone, while your ends is going to be that spongy bone. And so the epiphyseal plate / line is just kind of is a line of hyaline cartilage that kind of separates the two. The medullary cavity is what's going to be on the inside, so your bone marrow, anything that's inside, not the external part. And your trabeculae, if you're looking at spongy bone, just like a sponge, is full with holes and lines. Anywhere where there's not space, your trabeculae is lining that. So that's what kind of, if you could imagine, the sponge would be the trabeculae. And so I would just draw that, kind of do a cross-sectional. Let me grab what's next. And that's going to be part C. And part C is going to be your bone microscopic structure. And so we have this bone model. So if you can imagine, these are the exact same thing. This is just a whole lot more in depth. So your osteon is these big towers, or if you see in the 2D, the full circle is going to be what completes an osteon. An osteocyte, if you can kind of, I'll try to stretch it. See those kind of spider looking things? Those are your osteocytes. Your central Havasian canal is going to be this red dot right there. Or if we look on the side, it's going to be the up and down canals right there. Next, what we have are your perforating canals, and those are your transverse canals right here. And so both canals hold blood, but the transverse gives you blood throughout, while central is just going to that specific osteon. Concentric lamellae, so as you can see, those circles, each one of the big circles is going to be your concentric lamellae, while if you look in between the two, there's multiple circles. There's these lines right here that don't connect to the circles, and those are interstitial. So these are anything that's not part of the circle, part of the osteon. These ones are just going in between each one of the concentric. And so finally for lamellae, we have your circumferential, and that's going to be on the outside right here. And as you can see, that's not interstitial in between circles, but rather on the exterior of all the other lamellae. Finally, we have our lacuna. And so lacuna are the little holes in which the osteocytes reside. And so as you can see on the side right there, that's where the osteocytes are. The lacuna are, my mistake. Your canuliculi, see these little lines right there? So these are the little canals. That's what canuliculi means in Latin, is tiny canal. And so these are just what these are the little canals in which the lamellae are able to interact, and you can see really big ones right up there. Finally, we have your endosteum and your periosteum. So your endosteum is going to be what's inside of the canals surrounding the blood vessels, occupying the space in between the canals and the actual vessels. And your periosteum is going to be the outside layer right there, from which the perforating or Sharpey's fibers, these white ones, are going through. And so that's the ID for those ones. For part D, I'm posting a Quizlet just because I think a Quizlet can tell you better information than me with words pointing at some stuff on the bone. I think a Quizlet's a whole lot easier because you can quiz yourself on that a whole lot easier. Part E and part G we're gonna be talking about in class, because you can't pick those up very well on a computer camera. So obviously we're gonna talk about those later. Part F, articulation structure. What I want you guys to have written for those is we want 3 structures in particular written. So your structures that you want to have is your fibrous, cartilaginous, and synovial. And if you guys want to talk about like just being able to distinguish like fibrous being adjacent bones being bound by collagen fibers that emerge into each other, while cartilaginous, 2 bones linked by cartilage, and synovial, which is your joints. And we're primarily going to focus on synovial joints. So we can talk about the movement. So bony is very kind of immovable, obviously. And so the 3 types of movement, amount of movement that we want you to know are synarthrosis, which is immovable, amphiarthrosis, which is a little bit of movement, and finally diarthrosis, which is a lot of movement / free movement. And so your synovial joint structure, we'll show that in lab. That's a kind of a model that we'll have pictures, and I'll post those on D2L after you guys come through lab. It's just a whole lot easier. And then with H, that's another one that I want you guys kind of to being able to distinguish yourself. I can't really just tell you the information. You guys kind of have to figure that on your own. But the 4 different types of action, like axial movements, is what we want to have in the second one. So I'll go through gliding plane with you guys, just so you guys know what kind of information you should be putting down. So for the joint type for gliding or a plane, there's 2 different answers. There's non-axial and biaxial. And so it's the only one where there's 2, and it's because your book gives you biaxial, but realistically, there's not really any angular moment with the joint type of gliding / plane, and that's gonna be your carpals or tarsals. And as you can see, they kind of glide on it rather than being on the ball and socket, which is your biggest movement, widest range of motion, which is what I put for my observation for my ball and socket, with the representative choice of your hip or shoulder. And you can see with your shoulder, I can do it any way I want in any direction. So that is multi-axial instead of being, or if you have the saddle, which is your digits, only being biaxial, because there's 2 planes in which it can interfere with each other. And so that's everything for 6. We're gonna talk about I, articular movements. These ones are super easy, so let's just get started on that. So the different type of movements, we're gonna be always talking in anatomical position. So flexion and extension. Flexion is when you're coming against the anatomical position of this. So you see my biceps is flexing because we're against anatomical position, and your triceps brachii is gonna extend or return to anatomical position. We have abduction and adduction. Abduction, when you get abducted by aliens, your hands go up. I'm getting stolen. Adduction, you're adding back to your body. Rotation is gonna be your head left to right. It's rotating on its axis. We have circumduction, which is this. If you make a circle with your arm, that's the form of circumduction. Pronation and supination. The best way to remember these is supination, you're asking for a bowl of soup. And when you're a pro at asking for soup, you no longer have to ask. So that's pronation, supination. Dorsiflexion and plantar flexion. So I can't really show you my feet too well. That's gonna be, so dorsiflexion, pretend this is the heel right here, and these are the ball of my feet and my tips of my toes. So dorsiflexion, we're gonna be going up like this. The heel of my foot is down while my tips of my toes are pointing up, and your plantar, you're planting your feet. You're standing on your tippy toes. That's plantar flexion. Inversion and eversion, also talking about the feet. So pretend these are the tips of my toes, and this is the back of my feet right there. Inversion, your toes are touching. Eversion, they're going away from each other, kind of a penguin foot. We have opposition and reposition, and this deals with your thumbs. And so opposition, you're opposing your thumbs across each other. And while repositioning, you're repositioning them back to anatomical position. And finally, to end with, we have elevation and depression. So elevation, you're bringing your shoulders up, while depression, you're bringing it down. You're sad, right? And that's everything for exercise 6. I'm gonna be posting a TechSmith for J, which is the levers of the body. And just because that's kind of the tougher issue, that's the best way to remember that, is just have a slideshow. That's a big part of your exam for practical 2. And that's everything. Thank you guys.